she's presenting on the EWB project.
So, I'm Sophia Baybridge, and I'll be representing Engineers Without Borders, the Guatemala chapter of Michigan Tech. So the two communities we're working with are Canton and Confront. And so they're located at this gray star right here in Guatemala. It's kind of hard to see, but that's so they're within walking distance of each other. So they're pretty closely connected. So these first couple pictures are of Fronterizo, so it's just like an open space community area where they can gather. And it's kind of the similar space in Canton. So yeah, they use this area for gathering company space. And so in 2006, we first started working with Guatemala. So we took our assessment trip down there and to see what kind of help we needed or what needs. So one thing that was very prevalent was the water quality, the ability to obtain fresh water. So these are pictures of shallow wells. So these would deplete during the dry season. So like for a few months, they weren't able to have access to clean water. And so part of the problems with these wells too is that they're located right next to farmland too, so there's a bunch of bacteria that's being polluted in there. And it wasn't the greatest water. And they also did water quality testing too to determine what type of bacteria were in the water. And so in 2007, a year later, we went down and we actually dug some wells. So these are pictures of the well we've done. This stake right here is about 1 meter wide, so it just gives you a visual representation of how large the wells are. So this right here, they're caissons, and so there's the first 5 caissons. They don't have mortar used in them, so that way water can infiltrate through the well and easily replenish the well. And they're surrounded by bedrock, so around the first 5, and then everything up to the surface is surrounded by earth, and those are mortared and stuck together. So there was wells put in Canton as well as Fronterizo in 2007. And so in 2009, we went back down to take another assessment trip, and just to determine what other type of needs that the community needed in addition to water. And these are one thing that was assessed was the cook stoves. And so this is an ideal cook stove over here. It's ideal because of the ventilation and the chimney coming up. A lot of the cook stoves don't have ventilation, and so it's polluting, like it's contaminating the air within the house. So one of the side projects that we're working on are these cook stoves. So last year there was a cook stove team and we developed 2 different types of cook stoves in the basin that they have now. And so that we're working on that, we're testing those. This metal sheet right here, that they used to cook their tortillas on, and I don't know, not a lot of, again, this is the ideal cook stove, and that type of material is a little bit out of the majority of people's price range. So they use a different type of material, but so this is their main food source, this cornstarch bacteria, cornstarch vegetable kind of thing for food. And then, but the main concern though was in 2009, it wasn't just the cook stoves, it was also water. They needed more clean water in addition to what the wells that were already put in. So this is a pump that I'll talk about later. So in 2010, again a year later, we implemented 2 new wells. So now there's a total of 2 wells in each community, 2 in Canton and 2 in Fronterizo. And so this is again just a community effort showing how we work with the community to install the wells. So that's really important. Like we're not just designing projects and then putting them in there and then just leaving them. We're letting the community have responsibilities so that they have ownership. And so that way we can maintain later on. So this is a good representation of the teamwork of the community putting in place in 2010. And then so 2012. In May 2012, we went back down again to assess the wells and the pumps. So this picture up here is an example of the pump. But there's 2 schematics. This schematic is a cross section of the well itself. So this vertical line right here is the pump, and then so they're not. And then it stops like halfway. It doesn't go all the way to the bedrock. It stops about 3/4 of the way down. And so this is the pump itself. The Maya pump is what it's called. So how the pumps get to Guatemala is we purchase them from a supplier down there, and so they're locally made. So the pumps work. So they're made out of PVC, and the bottom part is called the strainer, and it's just a slotted like PVC pipe with a bunch of holes in it. And so that's how the water enters into the pipe. And so initially, when you're pulling up on the pump, the water will come through here. And it'll pass through. You have to prime it a few times to get the water, like enough water to rise up all the way to the top. So the water enters in through the strainer, and then when you, so it's in this part now. So when you push back down, it'll close this foot valve so the water doesn't leak back through the strainer, and it'll like go up through the rising main in between the inner cylinder and the outer cylinder. So you have to just consistently be pumping it in order for the water to rise up. And it took me a few times to like visualize this and like actually see it, so I don't understand. There's a part somewhere that we could show you, but and eventually it'll come out. And with these pumps, the depth, like the maximum depth that they can pump water out, I believe, is around 10 to 14 meters. So there's in these two wells, so in one of the communities, one of the wells is a little too big. Like it's about like 13 meters deep, and that's like the maximum like threshold that this pump can have. And so one of the pumps is, if you use it over time, it breaks down, especially if it's at its maximum threshold like that. So what we're working on is, so like that O-ring right here is breaking and deteriorating. So like that gasket, it's like, and the plastic parts are breaking too. So what we're working on this year is figuring out a way of purchasing more durable pumps or designing our own pumps that would last longer. So how we're doing this is we're using this land near the tech trails. So this plot of land is actually owned by the Forestry Club, and so what we're claiming this little group of trees right here. And so this if you don't know what this is if any of you are familiar with the tech trails, it's right next to the core loop. Or Pilgrim Road, the tech paintball trails are like down here. But so we actually went out a couple of weekends ago and we did seismic refraction testing to determine the water table to see if it would be similar to the water table in Guatemala, so we can test the life cycles of these new pumps to see how long they would last. So see if they would be feasible and worth implementing. So these are. We're not drawing any definite conclusions from this just yet because it happened a couple weeks ago and we do a little bit more testing, but this is the results of the seismic refraction testing. So what seismic refraction testing is you take this like metal ball and you lay it on the ground and you take a sledgehammer, you hit it multiple times repeatedly, and there's megaphones in the ground, like 15 to 20 of them or something. And so you hit, every time you hit the ball, there's a wave that's sent through the ground, and depending on how fast that wave travels through a certain type of material and reaches the megaphone, that'll determine what type of material it is, whether or not it's a bedrock or water. So each of these different slopes will tell you what type of material it is. So we believe that the water table is somewhere like here-ish. But again, we need to do more testing, and hopefully we'll do that in the next couple of weeks. But again, with this site, we're hoping to like test the life cycle of new pumps, drill a well, and but small little construction projects like that. We still need to do a little bit of permitting to ensure it. But we're also hoping to use this space for other D80 projects. So like it's just a place for other student organizations to make mistakes, I guess, before implementing. It's just a place to practice and experiment. So hopefully we'll expand from this clump of trees into this open field and then eventually just all work together. An open space. But anyway, I can answer any questions.
How do you dig the wells?
There is, we purchased it like down there or up here.
Either way.
Well, for drilling the wells up here,